All right, so it's a little blurry, but we're going to make it work. So in number 1, we need to recognize the fact that the square root of 16 is called a perfect square. So 4 times 4, why is this not working? Hold on, sorry guys. Okay, so 4 times 4 makes 16. So the square root of 16 is simply the whole number 4. So number 2, 28 is not a perfect square. So I do something called, I call it prime factorization because that's how you did it in like 3rd grade. So what makes 28? If it's even, I can divide by 2. So 2 times 14 is 28. 14 can break down into 2 and 7. These are all prime numbers. These are numbers that will no longer break down. So what we do is we take them out in pairs. I have a pair of 2s, and I have a loner named 7. So the pairs, if you had a friend, that group of 2s comes out. The loner is stuck under the doghouse in the square root. So the answer is 2 root 7. Let's try another one. Square root of 12. Square root of 12 is 2 times 6. That makes 12. What makes 6? 2 times 3. So now, these are all prime numbers. They don't break down into anything else. So I find the pairs. I have a pair of 2s, and I have the number 3. The pair comes out. The loner is stuck under the doghouse. So numbers 5, 6, and 7 all work the same way. Let's look at number 5 together. 5 is the same idea, but this way you don't get confused. So 24 is the same as 2 times 12. 12 is the same as 2 times 6. 6 is the same as 2 times 3. We can only take them out in pairs. There's a pair of 2s. This does not have a pair that matches him, and this does not have a pair that matches him. So the pair is a 2. The loners, there's a 2 and a 3. They're loners. So we put the 2 and the 3 together, so it's 2 root 6. 2 times 3 makes this 6. Number 7, same thing. Number 6, same thing. Just break those down. They're even, so you just divide by 2. You could also divide them by 3 if they're divisible by 3. Divide by 5 if they're divisible by 5. So you break down into their factors. You circle the pair, and you put the loners, the one that did not have a matching partner, goes into the doghouse. Okay, 9 through 11 are the same thing. Moving on to number 13. So in number 13, what happens here is we have a square root in the bottom. We can't have that. So we can never, ever, 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 ever have a square root in the bottom. So what we need to do to get rid of it, I multiply the top and the bottom times that square root. So on the top, 2 times root 3 is just 2 root 3. On the bottom, a square root of 3 times a square root of 3. I can multiply those together. 3 times 3 is the square root of 9. Square root of 3 times the square root of 3 is the square root of 9. The top does not break down, but the bottom, the square root of 9, is just the number positive 3. So that is your final answer here. Same idea, number 14. Square root in the bottom, that's not good. So we give the top and the bottom, that's square root of 2. The top becomes 4 root 2. The bottom, the square root of 2 times the square root of 2 is the square root of 4. Whenever you're multiplying radicals, you just multiply their numbers that were inside. Top gets to stay. Root 4 is the same as the number 2. Now these numbers can simplify because they're both numbers in the front. 4 divided by 2 is the number 2. The square root just gets to hang out right next to him. 15. We have a square root in the bottom, not good. So I give it to the top and I give it to the bottom. Square root of 3 times the square root of 2. Those are both under the radical, so we can multiply them together. That is the square root of 6. The square root of 2 times the square root of 2 is the square root of 4. 4 is a perfect square, leaving us with just a 2. I cannot reduce or divide because that's underneath the radical. 17. Root 6, goodbye. Root 6, goodbye. Whatever's in the bottom, I give to the top and the bottom. So this leaves me with a 2 that just gets to hang out up there. A root 3 times a root 6, I can put those together. That's a root 18. Over a root 6 times a root 6, I can put those together. That's a root 36. So that leaves me with 2 square root of 18 over square root of 36 breaks down to just the number 6. Now I can break this thing down. 2 over 6 becomes 1 over 3. I could divide those both by 2. So my answer is 1 root 18 over 3. One more like that. We cannot have the square root in that bottom, so I'm just taking that root 3 in order to get rid of it. On the top, 7 root 3 gets to hang out. On the bottom, there's a 2 hanging out in front. Root 3 times root 3 is root 9. Square root of 9 is the same thing as just the whole number 3. So the top was 7 root 3. Over the bottom, there's a 2 times 3, which is 6. So we get rid of the square root in the bottom by giving it to the top and to the bottom. Number 19, we just did this even easier. So number 19, when we're multiplying, we just multiply the numbers that were inside. 3 times 6 is 18. 3 times 6 is the square root of 18. However, we have to go back to our initial rules. 18 breaks down. That's a 2 times 9. 9 is a 3-0. 9 is 3 times 3. So the square root of 18 is actually a pair of 3s and a loner 2. So that's your answer for number 19. I think we have more like that on this page. We sure do. Ooh. Here's another. It's the same question. Weird. So number 25 is the same. So in number 25, whenever you're multiplying, you just do the inside times the inside. Root 6 times root 3 is root 18. We just multiply 6 times 3. 18 breaks down, so I break down its factors. 18 is the same as a 2 times 9. 9 is the same as a 3 times 3. No more numbers break down in this question. I circle the pairs. I take that number out. I find the loner. I put that number in the doghouse. Okay, so that's how we multiply. So the last thing is adding. I don't think you need to do 26 through 28. I don't think that that's part of this unit. I could be wrong, but I don't think it is. But 23, I'm pretty sure we do have to do. So in 23, we need to add. In order to add, we need to have like terms. What that means is I need for this square root to be the same as this one here. So to make them the same, I break it down. 12 is the same as 2 times 6. 6 is the same as 2 times 3. 2's get to come out. 3's are stuck inside. When that 2 comes out, there was a 5 out there, so we have to put them together. 5 times 2 is 10. The loner is a root 3. Plus, that plus. 27, let's break it down. It's not even, so I can't divide by 2, but I can divide by 3. 9 is the same as 3 times 3. Here is the pair that gets to come out and chill out there. Here is the loner. 3 goes out with the 16. 3 times 16 is 48. The loner is the root 3. So now if you notice in this question, we have a square root of 3 and a square root of 3, and we're adding. Adding means combine like terms. So we can combine 10 root 3s plus 48 root 3s, and it would give us 10 plus 48 is 58 root 3. Not too bad. So try the same thing with 24. Break down the numbers, so that way we end up with some like terms. We had to have a root 3 plus a root 3. 10 root 3s plus 48 root 3s is 58 root 3s. Okay? So try 24, not too bad.